Hey guys, welcome back to a new video. It's been a while since I did something with PCG. So in this video, I'll be showing you all how to make this nice railway track using PCG. And as you can see, it's completely editable. If I go, so I have all the controls for, let's say, like track distance. I can control that. We can control our track width. We can control our track height, of course, and lastly our track thickness, how we want. So if you want something more like this, if that's your thing, you can. Also, we have controls for our railings, like the railing distance, also your railing offset, like let's say if you want something like this. Also, the thing it's not mirrored here is because I have a faulty mesh with the incorrect pivot, so don't worry about that. Also, you have control your railing height, let's say something above and here. So it's a beautiful tool and easily controllable. So yeah, let's begin the tutorial. So for this demonstration tutorial, I have these two assets with me. One is this wooden plank which we'll be using for the track, and this railing which we'll be using as a railing at the side like this. So I made both of these assets using the modeling tool and added a random material to it. Do let me know if you all are interested in seeing a tutorial for that. But yeah, let's go ahead and continue with the actor. So I'll create a blueprint class type actor. Let's name it BP underscore rail track. Open it up and add a spline component to it. Okay, and yeah, drag it inside. Perfect. Next thing you want to do is add a PCG graph. If you all don't have that, just enable the PCG plugin, you'll get that. So PCG graph, create an empty graph. I'll name it PCG underscore rail track. Save. And inside your blueprint, add a PCG component, compile and assign your current graph to it. I think this is it for the actor. Now open up your PCG graph, this is where you landed, come to an empty space, and first thing we want to do is get the spline data, since we are using splines, and actor filter will be self. After that, you want to sample the spline sampler, and you want to change the mode to distance. And lastly, you want to do a static mesh spawner. I'll add a mesh entry and assign my mesh to it. Track underscore wood, this one. Save it. Let's see in our level. There you go. If you see this, perfect. But now we want to control the distance, and if, for example, some of y'all might be having a rotated plank, if y'all are using some other custom mesh, I'll tell y'all how to fix that as well in a minute. Y'all can just continue as it is for now. So let's first control the distance. So to do that, we need to modify this distance increment. So inside your actor, add a new variable and name this track distance. Type will be float, make it public, and I'll add it to a new category called as track controls. Okay, copy this name, and over here expand the spline sampler. and add a get actor property node, and in your property name add this track distance. Also make sure you give it a default value, don't keep it 0, I'll give it default value of 100, and add this to the distance increment node, and you can close this. Save. Let's check, and if you see now in the details panel you'll have this track controls. Let's increase the distance. Perfect. I think I'll keep something around 110. So perfect. Next thing we want to control is the width, and some of you all might have these rotated tracks. I'll tell you all how to fix that as well. So after spline sampler we'll add a transform points node. You can disconnect this and connect this to the static mesh spawner. So if you'll have a rotated mesh, just change the rotation min z value both in min and max, let's say 90, and you will see this is what you all might be having. So yeah, I'll revert mine back. So now we want to control the width. For my mesh, I know scaling y controls the width. So what you want to do is, okay, inside your actor I'll add a new variable after track. Actually I'll add a new variable. This will be my PCG scale vector, PCG scale vector, and this type will be vector. Make it public and add it to the track controls. Also in the description I'll just write do not edit inside editor. Compile that. Now I'll click on my track distance, duplicate this, I'll add a track, name it track width. The default value will be 1. Duplicate the track width. Let's do a track height. And lastly, duplicate track height. Name it track thickness. And compile it. You have all of these. Now come inside your construction script and press Alt and drag your PCG scale vector. That will automatically set it. And from here you want to do a make vector node. So for my mesh, I know the track width is y, track thickness is x, and track height is z. So how I know this is if I drag my mesh, as you can see, this is my thickness, this is my width, and this is my height. So you all can see for your mesh as well. And I'll connect that to the make vector node. Now copy your PCG scale vector node name. Inside transform points, I'll do again the get actor property, and my property, I'll copy this and connect this to your scale min and scale max. Let's save. Now let's see. So you have this details. You can control your track distance. Let's control our track width 1.5. Okay, something is wrong. Let's see. Open up your PCG file. Inside transform points, actually delete uniform scale and add absolute scale. I think that is the issue. And yeah, track width, you can see, can increase from here. Track height, also my track thickness. perfect, just like how I want. So this is it for your track. Now let's add the railings in the side. That should also be pretty easy. I'll just decrease the track width a bit, probably 0.8, 0.9. Okay, now let's add our railings. I want it in both the corners. Okay, so first thing we want to do is open up your PCG graph. Okay, so let's add the railing. For that, just duplicate this entire thing and come inside your PCG graph. Now first thing, I'll add a new variable. This will be my railing distance. Type will be a float. I'll add it to a new category called railing controls. Compile it, and yeah, inside your PCG graph, instead of track distance, I'll add railing distance. I'll disconnect this from the transform points node and connect this to, okay, actually we also need to connect this to the spline sampler. Let's see. I think it has added inside and it's the same mesh, that's why I haven't changed the mesh. So inside my mesh entries, instead of track wood, I'll add the other one, this. So yeah, I can decrease the distance, probably 80, you can see. Okay, perfect. So now some of you all might have it rotated in the right way. We do not, so let's control that. I know inside my transform points, just change the rotation Z value of rotation min and max or what to 90, and yeah, that should be fine. And the distance, railing distance, I know is 100. So okay, so now we want to add an offset to it, so let's go ahead and do that. So for that, I'll come inside my actor, add a new variable. This will be your railing PCG offset. Type will be your vector, make it public. Add a description, do not edit in editor. Compile it, and over here again, after setting the PCG scale vector, set your railing PCG offset. Same thing, make vector. X and Y for now we'll leave 0. Promote Y to a variable, and this will be your railing offset. Make this public. Add it to inside your railing controls, both of them, and default value of your railing offset, yeah, can be 0, that's fine. Okay, let's see. So here, if I change my railing offset, let's say 50. Oh no, before that, over here, instead of PCG scale vector, we need our railing PCG offset. I'll add that and connect this to your offset min and offset max. Save. So yeah, so now if you see, railing offset 50 minus 50, probably minus 100. Now let's add an offset to the height. That will be our Z value, I think, Z. So promote that to a variable as well, railing height, make it public, add it inside your railing controls, combine. So the height, let's say 10, probably 15, yeah. Now we want a function to mirror this exactly on the other side. So what we need to do is, okay, let's see how we can tackle that. So we need another static mesh spawner. So till here everything will be same. You can close this up. Duplicate this. So first thing we want to add will be our rotation. So 180 degree on our z axis. That will be the first thing which we want to do. So inside your transform points node. So I already have it as 90. So let's do 90 plus 180. So 270 is what I need. And we will remove this from railing PCG offset. I'll duplicate our railing PCG offset and railing mirror offset. And again, last thing, set this. What you want to do is make vector. The height will be same as your railing height, and for the offset what you want to do is take your railing offset and multiply this by -1. So that will give you your y. So okay, copy this now, and inside your PCG, instead of railing PCG offset, connect this, and from your spline sampler connect this. Let's see, and something is not right. Save. So let's see what. Okay, it says I think, okay, because this is not compiled yet. Compile, now it's fine. And let's, if it's not, just edit it a bit, it should work. Yeah, there you go. You can see something is off, probably. Let's give our offset something -50, 0. Okay, so the reason for why this thing is off is because if you see the mesh, the pivot is bit off. If you have the pivot proper, this won't happen, but yeah, right now we'll have to deal with this, so sorry for that. So my railing offset, I'll put it somewhere around -80, -80. So yeah, perfect. And yeah, I think that's it for this tutorial. You have this beautiful railroad, and yeah, again, if you are getting these weird, that's because you'll have to adjust the spline a bit accordingly. That's good. Just see, the better the spline, the better you'll get the results. So yeah, thank you for watching, and do subscribe if you like the video.